Hi guys, and welcome to another video, and today we're going to be looking at grade 12 inverse functions. Now if you watch the first video, you look at the definition of a function which we've already defined, and let me just go over it very quickly. What it says is that for every x value we need to have a unique y value. I'll repeat that. For every x value we need to have a corresponding y value, only one y value. Now an example of a function will be what we looked in the previous video, will be a straight line graph. Another example of a function that we're going to be looking at a little bit later will be an exponential graph. So that is known as a one-to-one function, and the inverse of a one-to-one function will also give us a one-to-one function. Now let's look at another example of a function, and we're going to be looking at the parabola today, and the parabola in the form y equals to ax squared. Now that is a many-to-one function, or many-to-one. It has a many-to-one mapping. Okay, and the reason it has a many-to-one, many x values to one y value. Right, so let's look at the general concept of the inverse of a function. We looked at that in the previous video as well. So what is the inverse of a function? Well, basically the inverse of a function is just basically a reflection about the line y equals to x. So what happens when we reflect any coordinate or point around that line y equals to x? Well, very simply, x, y becomes y, x. Swap our x and y coordinates around. In our previous lesson, we also looked at sketching a straight line graph and its inverse, and we looked at the concept of domain and range. Now that's very important, and once again in the previous video I mentioned to you that for a function and its inverse, the domain and the range is swapped around, and we're looking at the intercept with axis and shape. Once again we will be sketching graphs. So we're going to look at point 5 in today's video, and in point 5 it says determine and sketch the graphs of the inverse of the function defined by y equals to ax squared. Determine how the domain of the function may need to be restricted in order to obtain a one-to-one function, to ensure that the inverse is a function, and we're going to be looking at once again the concept of domain and range in functions and their inverses, intercepts with the axes, and so on. Okay, so what is, for example, the inverse of a function? And right, as I mentioned to you already, the inverse of a function is the reflection about the line y equals to x, and you have to remember that the rule for any reflection about the line y equals to x is x, y. We swap the x and y coordinates around, so it becomes y, x. And that is for any reflection about the line y equals to x. That is what inverse functions is about in a nutshell. So one other thing that you will encounter is the vertical line test, and with the vertical line test we are able to confirm whether any graph is a function. So we'll be given a graph, and to test whether that is a function, we just have to know that any line which is parallel to the y-axis is a vertical line, and if that line intersects our graph only once, then that is a function. If it intersects it more than once, then it is not a function. It is referred to as a relation. Now, the example of a relation will be a circle, because if we have to draw a vertical line across a circle, it would intersect it at 2 points. Therefore, a circle is not a function. It is called a relation. Now, let's quickly just go over the different types of mappings when it comes to functions. So for a straight line graph, this is in the form y equals to mx plus c, and this is a one-to-one mapping. That's a one-to-one mapping. And when we are now going to be looking at in today's lesson, so let's just quickly look at a parabola. So if we look at a parabola, and I just mentioned the vertical line test, see, it will only go through it one time. So this is y equals to ax squared. So this is referred to as a many-to-one function or many-to-one mapping. So that's an example of a many-to-one. Now these two, a straight line graph and a parabola, are examples of functions. Now what does it mean? One-to-one mapping means for every x value we'll get a unique y value. Once again, here we'll have more than one x values, but we will get a unique y value. Therefore, the parabola is a function. Examples of relations will be, now the inverse of a parabola, and let's look at that one. The inverse of this parabola here would look like this. So, if you look very carefully, this is referred to as a one-to-many mapping. And as you can see by the vertical line test, it would intersect this particular graph at 2 points, therefore this is not a function. And lastly, let's look at a circle. So once again you can see that by the vertical line test, it would intersect it at 2 points, therefore this is not a function, and this relation is referred to as a many-to-many relation. Okay, so in a nutshell, we should know what a function is, we should know the definition of a function, and we should also know what the vertical line test is. Okay, so very quickly, remember that a function is where we have, for every x value, we must have a unique y value, and functions and the inverses is the reflection about the line y equals to x, and there's the rule for reflections about the line y equals to x. Okay, so let's move on. Now, today I'm going to be looking at the parabola and its inverse. So I'm going to be looking at y equals to ax squared and the inverse of a parabola. So let's just look at some theory very quickly. So let's look at an example. The example will be, let's say, f of x equals to x squared. So I'm looking at a parabola, very simple parabola, that has a minimum value. So if we have to just roughly sketch it, it would look like this. Okay, it's a very rough sketch. Now this is just to illustrate to you what we are basically dealing with. So let's say this is my function f, which it is. Now let's look at the inverse of this particular function. So f inverse would now look like this. Now so as you can see, for f and f inverse, you clearly see that f is a function, f inverse is not a function, because this would now become, as you can see, a one-to-many mapping. So from a many-to-one to a one-to-many mapping. Therefore, we have to restrict the domain of f in order for inverse to become a function. So let's look at how we can do that very, very quickly. So let's say that we have this particular function, which is f, but let's now restrict the domain as follows. Let's say that the domain D will be x, D for domain x greater than equal to 0. So therefore, if x is greater than equal to 0, the function now should look like this. So therefore, that is now f. Now remember that all functions and the inverses are a reflection about the line y equals to x. So can you look at the inverse? So the inverse would basically look something like that, because remember that it's going to be a reflection about that line y equals to x. Alright, so that would now be f inverse. So now what can you tell me about a function and its inverse? Well, you can see that it's firstly, it is symmetrical about the line y equals to x, but also you are able to say that if we now limit the domain or restrict the domain, you can see that the inverse is also a function. So let's look at the domain and range of f. So what is the range of f? So the range of f will be, there's f here, will be y greater than equals to 0. So that's the domain and range of f. So let's look at now the domain and range of F inverse. So F inverse, the domain, and there's F inverse here, will also be, remember the domain and range are swapped around, so it will be x greater than equals to 0, and the range will be also y greater than equals to 0. Okay, now let's look at the next aspect of the very same graph, but let's look at it now if we are to restrict the domain where we now say x less than equal to 0. Let's see what happens. So basically we're only going to be drawing this part here. So now going to be as follows. So let's say that we only draw that part, because we are saying now that we're going to restrict the domain to say that x is less than equal to 0. Now remember, x is less than equal to 0, and let's call that f, because it is f from our previous drawing. And remember, the range will be y greater than equals to 0. Okay, so that's the domain and that's the range of f. Okay, so this is the domain and range of f. Now remember that the function and its inverse is going to be reflected about the line y equals to x. So there's the line y equals to x. So let's see now. So the reflection, as we can see from what we've drawn already, is going to be this part here. So it's going to look as follows. So that's f inverse. Now what will this domain and range of f inverse be? Well, the domain, as we can see here, will be x greater than equals to 0, and the range now is going to be y less than equals to 0. And now that is for f inverse. So let's look very carefully at that. So let's look at the domain of f here. The domain of f is x less than equal to 0. Now look at the range, y less than equal to 0. See, domain and range is swapped around. Here the range is y greater than equal to 0, and here the domain is x greater than equal to 0, which is in keeping with, remember, our definition and what I told you, that the domain and the range of a function and its inverse is swapped around. Now remember that we have to basically absorb all of this theory before looking at any examples. Always read first, remember to summarize, and then to practice with the examples that you have. And remember that all the videos that I do, you must try to answer the questions first before you look at the solution. Now let's look at an example that came out in, I think it was in November 2018 paper. So this is from November 2018, and this is a question on a function and its inverse, and more precisely a parabola, as you can see here. It says in the diagram below, the graph of f of x equals to ax squared is drawn in the interval x less than equal to 0. So here we have a restricted domain, as you can see, x less than equal to 0 to give us the graph of f. It's telling us that the graph of f inverse is also drawn, and they give us a point on the graph which is -6 and -12. So that's a point on f, and r is a point on f inverse. So let's go and look at this particular graph. Everything is here. There's the graph of f. This is the graph of f inverse, and if you look at the theory that we went over, you are able to see that it is very, very similar to what we've been dealing with. Now the first question that they're asking us here is f inverse a function? Motivate your answer. Now the solution to that will be, because they've given us with a restricted domain, it has to be yes. And we can see it in many ways that f inverse is a function. We can look at it in terms of a vertical line test, or we can look at it in terms of looking at the mappings. It's a one-to-one mapping, or we can tell them for every x value there is a unique y value. The solution to the first question in 4.1 will be yes, and we can tell them for every x value there is a unique y value that is a 1 to 1 mapping. Okay, so that's our solution. There's a 1-to-1 mapping, and yes, it is a function because for every x value there is a unique y value. Let's look at the next question. If r is the reflection of p in the line y equals to x, write down the coordinates of r. Now once again, reflection about the line y equals to x is basically what functions and inverses are all about. And remember the rule that I wrote earlier on, that x, y, this is the rule, will become y, x. And this is a rule from transformation geometry that we've done in the earlier grades. So therefore, all we're going to do is just swap around x and y values. So the coordinate r is now going to be minus 12 and minus 6. That will be our solution for 4.2. Say r is negative 12 and negative 6. 4.3, calculate the value of a. So let's look at that. Calculate the value of a. So f of x equals to ax squared. When you are going to calculate an unknown value, any function for that matter, we need to locate a point which lies on that particular function. So we can clearly see that they give us on point. If you have to look at it very carefully, on point on the graph f to give us the point p minus 6 and minus 12. So therefore, we can just substitute that coordinate into the function and solve for a. So for 4.3, we're going to substitute p negative 6 and negative 12 in f. So we get minus 12 equals to a times minus 6 squared minus 12 is going to equal to minus 6 squared is 36, so that will be 36a. Therefore a minus 12 equals to 36a. Therefore a is now going to equal to, so minus 12 over minus 36 is minus 1 over 3. So the answer for a is negative 1 over 3. The next question says, write down the equation of f inverse in the form y. So let's look at that very, very carefully. Now that we have the equation of f, we can write down the inverse of f. So for 4.4, let's have a look at that. So what we're going to do is, we firstly going to write down what f is in terms of y and x. So y is equal to, what's a, minus 1 over 3 x squared. But it's important for us now to also make sure that we write the restriction down with that. Remember that the domain that they gave us for f is x greater than equals to 0, or it's less than equal to 0. So x is less than equal to 0, and the range of f also is y less than equal to 0. And let's just double check that very quickly. So if you look at f, there's it here, x is less than equal to 0, and the range is y less than equal to 0, and there's it given here. The domain was given to us as restricted. So moving on, now let's write the inverse of this particular function. Now what do we do when we write inverses? Well, basically to write the inverse is just basically swapping the x and the y values around. So it will be x equals to minus 1 over 3 y squared. Therefore, I'm solving for y, and the easiest way for me to do that is to get rid of this negative 1 over 3. So I'll multiply by negative 3. So I'll get minus, if I multiply by negative 3, minus 3 x equals to y squared. Therefore, y will equals to, if I take the square root of both sides, plus minus the square root of minus 3x. So, let's write down the domain and the range of our inverse function. So remember, the domain and the range is going to be swapped around. So this, remember, this domain is x less than equal to 0. So the range will be y less than equal to 0. This range is y less than equal to 0. So this domain will be x less than equal to 0. Okay, so what does this tell us? So it tells us that the y value is going to be negative. So y has to be negative value, so it will be minus square root of minus 3x. Now that's very important because we have to make sure that we adhere to the restrictions. And what's the other thing that you have to take note of as well is that x must be less than equal to 0. And x has to be less than equal to 0. Otherwise, remember that this function will be non-real. So it's important for us to write y equals to minus the square root of negative 3x, and x is less than equal to 0. So make sure that you adhere to the restrictions when you are doing your solution. So learners, once again, remember, for a function and its inverse, we're just swapping the x and the y values around, and we're writing our equation in terms of y. If you haven't subscribed to my channel already, subscribe to JL Maths, and you can check out my videos on jlmaths.com. And I'll catch you in the next video.